Let's get right into it. We are surrounded by these incredibly powerful AIs, right? They can write code, they can create poetry, they can think through some really complex stuff. But, and this is a big but, they all have this one massive, frustrating flaw. They basically have the memory of a goldfish. So in this explainer, we're going to break down exactly why your AI assistant keeps forgetting everything and how a brand new standard is finally giving it a brain that can actually remember. You know exactly what I'm talking about. You spend hours, maybe even a whole day working with an AI. You're teaching it your project's entire architecture, your personal coding style, all your little preferences, and it feels like you're really getting somewhere. Like you're building this shared brain with a partner who just gets you. And then poof, it's gone. You open up a new chat window and it's like you're talking to a total stranger. Every bit of that context, all that shared knowledge just vanishes. And you have to start all over again from scratch, explaining everything. Look, this isn't just a minor inconvenience. It is the single biggest bottleneck holding AI back from being truly useful. This quote just hits the nail on the head, doesn't it? Today's large language models are what we call stateless. They're absolutely brilliant in the moment, but they have no continuity. They lack that persistent memory that really separates a simple tool from a true assistant. Every single time you talk to it, it's a blank slate. Okay, so how on earth do we fix this? Well, a solution is starting to take shape, and it's called the Model Context Protocol, or MCP for short. Think of it as a new, standardized way to give AI a long-term memory that can work across all kinds of different apps and agents. So what is it, really? At its heart, MCP is just a set of rules for communication. It creates a standard way for any AI agent to save information, to pull it back up later, and to update it, all from an external memory source. This creates a kind of universal language for context, which means memory is no longer trapped inside one little conversation window. You know, the best analogy for MCP is the USB-C port that's on all your gadgets now? Remember before that, every phone, every laptop had its own weird proprietary plug. It was a total mess. USB-C came along and standardized everything. Well, MCP is doing that exact same thing, but for AI memory. It's creating one universal port that any AI tool can just plug into to access a shared pool of knowledge. So let's break down how this actually works, because this is the important part. First, MCP is that universal connector, right? It lets totally different tools, like Claude and Cursor, talk to the very same memory bank. This creates a shared space for knowledge. But here's the real game changer. It separates the memory from the AI model itself. The AI's brain and its long-term memory are now two different things. And that means the context can live on long after you've closed the chat window. All right, so if MCP is the communication highway, how does that help us actually build the AI's brain? How do these agents organize and manage all this new memory to give us that helpful, stateful assistance we're all looking for? This is the huge shift we're talking about. We are moving from stateless AI, the kind that starts over every single time, to stateful AI. A stateful agent remembers your preferences. It maintains context from something you worked on days or even weeks ago. It adapts to you over time. This is what transforms the AI from a simple, one-off tool into a genuine assistant. And building this kind of memory isn't just random, it's a systematic process, a lot like how our own brains work. First, the agent generates new memories from your chats. Then it stores that information in a really structured way. Later, when you need it, it can retrieve the relevant context. As you give it new information, it updates what it already knows. And this part is so important, it even knows how to forget. Not just deleting things, but intelligently archiving or downranking information that's just not relevant anymore. And the way researchers are structuring this memory is pretty fascinating. Some are building what's called hierarchical storage, just like a computer's file system, with short-term, mid-term, and long-term memory. Others are using ideas from a note-taking system called Zettelkasten to create this dynamic web of tiny, interconnected atomic memories. This actually lets the AI find new connections it wasn't explicitly taught. And maybe the coolest part? They're building goal-oriented agendas. And this gets to a really critical point you can see in the research. An advanced AI with this kind of memory doesn't just remember what you told it, it remembers why you told it. It's tracking your goals, its own internal goals, and the plans it's trying to execute. It can actually reason about your intentions, which, wow, is a massive leap forward towards something that feels more like human collaboration. Okay, that's the theory. It all sounds great, right? But what does this actually look like when the rubber meets the road? Let's walk through a real-world example of how this shared memory can completely transform a normal workflow for our developer. Okay, so imagine you're starting a new project. First, you hop into Claude to brainstorm the whole plan for a new time tracking app. It helps you outline the tech stack, all the features, the layout, the whole shebang. Now, here's the magic. Claude saves that entire detailed plan to a shared memory server using MCP. Then you switch over to your code editor, Cursor, and you just say, okay, start building that time tracking app. And because Cursor is plugged into that same memory server, it instantly retrieves the full plan and just starts writing the code with perfect context. No more copy-pasting, no more re-explaining anything. That right there is the power of a persistent shared memory. So let's zoom out. What does all of this really mean for the future? Well, this ability to remember is what's going to elevate AI from just being a bunch of disconnected, powerful tools to being a coherent, reliable teammate. And you're going to feel the impact of this everywhere. Just imagine a healthcare AI that doesn't just see your latest blood test, but remembers your entire medical history and spots some subtle pattern that leads to an early diagnosis. Or think about an education tutor that remembers the exact type of math problem you struggled with 3 months ago and customizes today's lesson just for you. We're moving from just getting answers to getting continuous, context-aware support. And that leaves us with one last big question. As these systems get better and better, with memories that can span years and cross between different applications, are we just building a better hammer? Or are we actually creating the very first generation of true digital teammates, partners that can learn, adapt, and grow right alongside us? The quest for persistence is on, and honestly, it's changing everything.